Okay, here we're going to look at rates, but they're unit rates. They're per one, like miles per gallon, students per teacher. They're typically referred to, they're typically preferred if the number is not a very small. Like, for instance, we did that one with births per woman, 0.05897 births per woman. It's not very helpful, all right? But many times we have rates per one, like $2.80 per 1 gallon, $13 working per 1 hour. Those are unit rates because they're per one. So this example, just a grocery store has 3 pounds of grapes for $5. What's the unit rate? Well, you can set the proportion up: pounds, dollars, cross multiply, and divide. But the other thing you can do is just divide 3 by 5. Any number over 1 is itself, so 3/5 equals the number of pounds, which is 3/5. So we get 3/5 of a pound of grapes for $1. Pounds per dollar. This is not what this number just goes here. It's still a rate. Still a rate. Switching the order of the ratio gives us a different unit rate. So here we're going to go to the grocery store. We're getting the same $5. We get the same 3 pounds of grapes. What's the unit rate? In cost per pound. Notice the difference. The other one was pound per dollar. This one is dollars per pound. Cross multiply and divide, and you get 5/3. Notice both of these unit rates in the last example are reciprocals of each other: 3/5 and 5/3. You can go back. Here's the 3/5 here. When you do it the other way, the rate, this is pounds per dollar, this is dollars per pound, this is 5/3. Also note that to compute unit rates, we can simply divide the two quantities because we want the second quantity to be 1. In other words, if you take 3/5 and just divide it, you get 0.6 over 1, which would be 0.6 pounds per dollar. Or you take 5/3 and divide it, and you get $1.67 per pound. So here's the one we're going to do. You spend $39.90 to fill up your car with 14.3 gallons of gas. You want to know the price per gallon. Now I'm going to set this up as a proportion. And you can do that too, but hit pause and set it up. I'll display it. So there is the problem then using cross multiplication. Cross multiplied and then divided, right? 14.3 is the same thing as 1430, whatever. And I get 279. But when you're just trying to find the unit rate, notice that 39.90 divided by 14.3 gives you the answer. So I really didn't have to set the proportion up, I just had to divide, which is probably what you would do anyhow. If I asked you 39.90 for 14.3 gallons, you can just divide it, and you're going to get the dollars per 1 gallon. Okay, this is really important. Most students, they forget this. When you're dividing a ratio, like we're doing here, this is the ratio, it's important we not forget about the bottom number, or thing 2, this thing. A lot of times students will just divide and forget what it is the answer is. Thing 2 does not disappear, but always becomes 1. It's an important element. So here is unit rates for comparison, right? They're good to compare. I got 16 ounces, 16-ounce can of pears for that much money, while it costs $2.88 for 12-ounce can of pears. What's the better value? The better value is not always the one that comes with the most. Actually, stores will trick you, and the more is not necessarily the better price. So I would press pause and think about it, and I'll put up the answer. So there's the answer. Notice I just divided. I set up the ratio and I divide it. And I don't forget that bottom one. So in this case, the 288 for 12 ounces is a teeny bit cheaper, less expensive per ounce. Now, if you flip this and divide backwards, you can still do the problem, but you're going to have to interpret it differently. So, in other words, if I divide it instead of dividing 389 by 16, if I divide it 16 by 389, you have to be careful in interpreting the result. This is the mistake students make. Okay, so I'm going to flip these around and put them up here, and we'll discuss that. Okay, so notice that I flipped it around and I just again divided. 16 divided by 3.89, and I got 4.113, and that's ounces over $1. Same thing here, and notice if you just interpret this, and I should have put ounces here. If you just interpret this, you'll see that you get more ounces for each dollar here. So this is the better value. So you just got to be really careful. I strongly recommend writing down the units, thing 1 and thing 2. So a unit rate per capita means per person, and is computed by dividing by a population. All right, so we're going to look at a unit rate, but it's going to be per person. Okay. Computing rates per person involves dealing with number words like thousands, millions, billions, trillions. Knowing how to do this arithmetic is really important. So thousands is 10 to the third, right? Scientific notation, and that's how a lot of times you'll see it on a calculator. It'll just say E plus 12. So thousands is 10 to the third. Millions is 10 to the sixth. 9, 12. Thousands, millions, billions, trillions, 3, 6, 9, 12, 10 to that power. Writing scientific is very useful when we're dealing with very large and small numbers. So write the amount of money spent on Social Security in 2013, which is 808 followed by 9 zeros. To do this, we move the decimal 11 places to the left. That's the same thing as dividing by 11 tens, and this is from chapter 3. So we start with the number here. That's where the decimal is, and we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. If you divide it by 11 places and get 808, to get the same number back, you have to multiply it by 11 tens, because that's what you're doing, dividing by 10, dividing by 10, dividing by 10. Scientific notation always has a whole number and then a decimal, and then the rest of it. Let's do it the other way. The chance of winning the Powerball lottery just purchased is 0.0000133. I'm going to write this number in scientific notation. And you can read that, but I'll just explain it from here. Every time I move the decimal this way, to get to 1.33, I am multiplying by 1 10, multiplying by 2 tens, multiplying by 3 tens, etc. If I get it to here, I multiplied it by 8 tens to get this number. To get the number back, you have to divide it by 8 tens. That's 10 to the negative 8. That means divide this number by 8 tens. So these numbers are equal. Try and put this down. So it says in the real world, numbers are often very large and often very small. The national debt passed $21 trillion in 2018, and the diameter of a human white blood cell is 0.000005 meters. being able to understand and work with both very large and very small numbers is extremely useful in many science classes. So I'm going to put this in scientific notation, and then I'll put here how it comes out in your calculator or an Excel notation. So that's the end of this video, and we'll come back and we'll review this, and then we'll move on.